video and...
All right, hi guys. This Miss Kaufman and Miss Whiteside back with you, and we are going to have our second video on forces and just a real brief review of the first law. Newton's first law of motion was that an object at rest would remain at rest unless acted upon by an outside unbalanced force, and an object in motion will remain in motion unless acted upon by an outside unbalanced force. That is just a quick review of what Newton's first law. So today we're gonna find out what his second law of motion is. And I wish there was some kind of real, Miss Whiteside and I were just talking about this, some kind of catchy phrase that we could use that will make it easier to get this, but unfortunately there's just not. So I'm gonna read this to you. It says, this law states that the acceleration of an object increases with increased force and decreases with increased mass. And I guess maybe a simple idea, if you have ever, and I know none of my kids have ever done this, I'm sure, snuck up to Walmart or something in the evenings with your friends and got a grocery cart out in the parking lot, okay? Well, if the grocery cart doesn't have anything in it and you are pushing it as hard as you can, it will accelerate at a certain speed and go a certain distance. And the more people you put in the cart, the less acceleration there will be and the less distance it will cover. So I guess maybe that's kind of the best way for me to explain this. Probably the easiest way to remember this is force is equal to the mass of an object times its acceleration. F equals ma. And we mentioned this, I think, at the very first part of this, that the unit of measurement for force in the SI system, which is what us old timers call the metric system, is the Newton. Okay, and obviously it's named after Sir Isaac Newton in honor of him. When you're watching this video at home, you're going to also have 3 video clips that are on the science event that I think are really good. I put them on there so that you see some really good examples of Newton's second law of motion. Okay, if you did not get the definition for a Newton the first time we did this, then now is going to be a good time for you to do this. This is number 11 on your motion and forces study guide. And it says 1 Newton is equal to the amount of force that it takes to accelerate 1 kilogram of mass 1 meter per second. And that's not a mistake. And as a matter of fact, we learned previous to this that the units that we use to measure acceleration, you can spell it out, meters per second, or you can do it like this, meters / S2, which is meters per second squared. I prefer the short version on this. All right, 1 Newton is equal to 1 kilogram times meters per second squared. I'm going to show you something that's going to make this make better sense to you. Oh yeah, we have another triangle.
We love our magic triangles.
We love our triangles. Okay, this is set up the exact same way as the distance, speed, and time triangle, but we've got some new stuff in it. We're going to put newtons, our force, in newtons up in the top compartment, and then mass is in one of the bottom compartments and acceleration is in the other. Notice I've got my multiplication sign in between the mass and the acceleration, and I've got my divide signs here between the force and the mass and the force and the acceleration. And guys, you're going to get a worksheet where you're actually going to have to use this new triangle to help you calculate force, mass, and acceleration. Okay? All right. So real quickly, let's take a look at this top part of this. It says, if you have a little, I don't know, a little cart, a little car, toy car of some sort, and you push it, as long as there's not a lot of mass on it, a lot of weight on it, it's probably going to go pretty far because we're a lot bigger than a toy car. If you load it down with a bunch of mass, if we took a bunch of weights and just piled it on there, then even if we push it just with the exact same forces we did before, because this mass is greater, it's not going to accelerate as much. And you're going to actually get to do a 2-day lab where you are going to do like 16 different stations, and you're going to rotate through them, and you have to identify which Newton's law you see. And that lab is the best thing I know to do to get you where you understand this. All right, and this is the last screen I'm going to show you for today. And this is pretty good too. Okay, I got a guy here. He's got a golf ball down here and a golf club. And, you know, if you've ever watched golf on TV or whatever, the professional golfers hit that golf club with a pretty good force. So they apply a force to a little bitty small ball, which has a small mass. And as a result of it, that ball accelerates like crazy, goes way far. I can't even figure out where it goes. I've never been able to do that. If we took, though, that same amount of force, the exact same amount of force that this man is applying to the golf ball with the golf club, and instead we applied it to this great big truck, well, now we've got something completely different happening, because the same amount of force pushing a great big massive truck is only going to put out just a teensy tiny little bit of acceleration. And if you can't see that, that's a tiny little A for a little bit of acceleration. And it all works out. Force is equal to mass times acceleration. And that's it for today.